great pleasure to have Paul Leonardi here today. He is the Duca Family Professor of Technology and Management. Whew. There you go. But most of us know him as Paul. So
That's much better.
yeah. As usual, it's a great pleasure to have him. We're going to go around the room, have everybody introduce themselves, so he knows who's here, and then we'll get started. So I'm Shane Greenstein, coming from the Technology and Operations unit.
I'm Emily Irving. I'm a first-year doctoral student in the macro OB program here at HBS.
I'm Emily Drulove, and I'm an assistant professor in the OB unit here at HBS.
Frank Nagel, I'm in the strategy unit here at HBS.
I'm John Lervik, a visiting scholar from Norway, staying at the Weatherhead Center this year.
Chiara Farronato from the Technology and Operations Management unit.
Ethan Bernstein from OB, and more importantly, a co-author.
Diane Williams, computer scientist and tech entrepreneur, alumna of Sloan and Harvard.
So Dahl Neely, Paul's academic sibling.
Very well said.
And OB unit here at HBS.
Rory in the Tom unit, also overlapped with Paul in grad school.
Jerry Kane, a visiting scholar from Newton at Boston College.
Wanda Wikowski, faculty in Sloan in Information Technology and Work and Organization Studies.
Ryan Allen, I'm a PhD student in the Tom unit.
Matt Higgins, I'm an RA here in the Tom unit at HBS.
I'm Alan, I'm a PhD student at Sloan Work Studies.
Hi, my name is Ren. I'm a PhD student here in the Business Economics unit.
Jeannie with the Digital Initiative.
Lindsay, a third-year doctoral student at the Tech and Operations Management.
Natalia, PhD student in strategy here.
Okay, thank you.
Great. All right. Well, thank you so much, Shane, for inviting me to come today, and Jamie for all of the getting the accommodations squared away to make it possible for me to be here. I really appreciate it. People have said this is an unfair opening slide. That's kind of the point. I'm always hoping that there may be potential doctoral students or faculty members in the audience in the dead of winter in the East Coast, like I said. Maybe UC Santa Barbara could be a place to land. I'm going to talk today about a project that I've been working on for a number of years, and it's a comparative study that looks across 3 different occupations that are using digital simulation tools. And I'm going to talk only about a piece of it, urban planners, and we'll discuss what urban planners do and why I'm going to talk about them today. And this is very much a work in progress, so I don't have, well, I've got a draft of the paper, but I was too embarrassed to share it at this stage. So I'm hoping to hear your feedback on it and suggestions for improvement and paths that I might go down. I'm working with a PhD student, Virginia Level, on this project, and we think we've got a good idea for our framing in mind. We think we understand what the interesting empirical phenomena is that we want to explore, but there's still a lot of work left to do, so I really appreciate your feedback. And I'm happy to take questions throughout. I notice there's a lot of PhD students in the room. Sometimes it's fun to ask questions about how you make different kinds of research decisions. So if there are those meta kinds of questions that you'd like to ask, I'm happy to entertain those too along the way. I do want to make sure to get through the end of it, so if we get too far off on questions, I might have to put a little bit of a pause on it so we can reach the end of the presentation. But other than that, feel free to ask. Well, sound good? I felt like because I was at HBS, I should have an agenda slide. So this is what we're going to accomplish, at least is my hope about what we will accomplish in the study. What I'm going to do, because I know this is an interdisciplinary audience, is I'm going to be very light on theoretical foundations and heavier on empirical motivations. And the idea is to get you excited and interested about why this topic about digital simulations and hyperreality is something that you should be interested in and care about. And then as I try to convince you of that throughout the study and the findings, we'll discuss some of the implications both for theories of organizing but also for how we think about managing in a context where we're using digital simulation tools. Sound good? Okay. All right, so I want to start off with some definitions because we use the term simulation a lot, especially in teaching in a business school context. We run simulations in our classes. And simulation can mean a lot of different things, and when we throw the word digital in front of it, simulation can take on a slightly different connotation. So I wanted to start with a definition that I think is relatively good. I forget what dictionary I pulled this from, but there are different definitions of simulation, but this one is good because it talks about the imitative representation of the functioning of one system or process by means of the functioning of another. And this is an important place to start this presentation because at its core, what a simulation is attempting to do is say there is a system out there that we want to explain, and we will construct an alternative system, in this case one that lives digitally on our computers, and we will use that to imitate what happens in the other system. So this will become an important point later in the presentation, but there are always two systems that we're talking about. A quote-unquote reality that exists apart from the math that's going on inside the simulation tools that we're using on our machines. And I say quote-unquote reality because this distinction about what makes these two systems different and where these two systems converge and how they affect each other is going to be one of the core points that I want to discuss today. Simulations, at least in the digital context, are really nothing more than a collection of algorithms, right? There are computational algorithms that are using a number of random sampling techniques in order to arrive at numerical results. Those algorithms are often opaque to the people that are using the simulations, and I'll give you some examples of what some of the algorithms look like in the simulation tool that I'm using here. But again, what's important is that the algorithms are typically constructed via a number of differential equations that are running in the background. And the reason they're doing that is because they're trying to predict something. And the whole point of creating a system that represents another system or imitates it with a set of algorithms is so that there is a cost advantage or a time advantage, or perhaps a time and cost advantage together, of being able to run an analysis or an experiment in a system that's digital, which we can do very quickly, that we can iterate on, really almost without stop. And we don't have to perturb or make changes to the system that we're trying to model, which is very time intensive and costly to do. Today, the vocabulary that we're seeing in the business world is starting to shift away from simulation to this notion of digital twinning. And digital twins and simulations are very related, but they're not identical. So a simulation could be considered to be a digital twin if in fact it is representing or attempts to represent mathematically a separate context. And part of the reason that we call them twins is because what companies are doing increasingly these days is outfitting the physical reality, right, whatever that outside thing is that we're imitating on the digital tools, outfitting it with a number of different sensors and accelerometers and data gathering instruments, such that we can update in real time the mathematical simulation model based on changes that are happening in the analog physical world. So they're twins because they're constantly, the real world is updating the digital model. Now, the purpose of doing that, of course, is that we could then do things to the digital model, make changes in it to simulate what's going to happen in the physical world before we make those changes. I gave a talk a couple of weeks ago in southern Arizona for a major mining company that is looking to create a digital twin of its new mine. It's going to be a copper ore mine in southern Arizona. And they're very interested in trying to understand how can we outfit the mine with the right kinds of sensors that will provide the right kinds of data that we need to keep our model continuously updated. And a big part of answering that question is understanding what do you want to accomplish in this math-based world so that you can decide what data we would need from the physical world to make those changes in the math-based world that will give us predictions that feed back into the real physical world. Okay? I'm using real here very loosely. I probably shouldn't, and you'll see why in a couple of minutes. But note, two systems. Okay? So let me give you some empirical motivation about why this focus on digital simulation tools and digital twins is important. If you look across a number of different occupations or industries, simulation is becoming increasingly central to the work that goes on in them. I won't go through all of these, but anything from surgery to trading to electrical futures to manufacturing, simulation tools are used to try to make predictions about how can we optimally design a system or a set of procedures or behaviors or missions and do that in this low-cost environment, low-stakes environment, before we implement in the real world where the consequences are very high. I first became interested in this issue when I was a PhD student in studying automotive engineering. And the figure on the left is a screenshot from a digital simulation tool run on top of a set of technologies that do finite element analysis. And the picture on the right is from a laboratory. And you can see that what's happening in the simulation is representing the vehicle in the laboratory. And what engineers will tell you that do crash testing is that, of course, we want to build as many simulations as we can, not only because they help us to iterate much more quickly and arrive at an optimal vehicle design, but they're so much less costly. It costs about $650,000 US to build one of these pre-production vehicles and crash it into a wall, right? It's extremely expensive, not only because you need to build a bespoke vehicle, but you have to pay for the infrastructure for the testing facilities, you have to instrument them with accelerometers and sensors all over the vehicle in order to pull out the right kinds of data. Now, a good modeler will then take those data as a baseline, usually from a vehicle that was developed 5 or 10 years ago. They'll feed them into their digital simulation models as a baseline, and they'll start to run a set of analyses to correlate the model with the activities that are happening in the physical world. What is kind of peculiar about this, however, though, is that while the digital is supposedly standing in for the physical, the management of the engineering workforce at places like General Motors are very, very concerned that the engineers will treat the digital as though it is the physical. So when I arrived at GM, I got a training manual, and that training manual was for engineers who were doing computational analyses. And it was this thick binder about this big with tabs in it, and the tabs marked different sections, and the first page behind every single tab was this printout. Don't believe that the model is reality. So every time they turned to a different section, this was the first warning that they got. And I asked the question constantly, well, why in the world would they think that the model is reality? When the model is clearly a representation of reality. It's not the reality itself. And these are engineers that are building the model, and in some cases probably tweaking it with parameters that couldn't happen in the real world. So they, of course, wouldn't ever confuse one with the other. That picture became a little more complicated for me as I progressed along with this study. And an engineer mentioned at some point something that was quite common. He said, most people think that the vehicle on the road is what's real. But for us, the sled test in the lab is what's really real. And the simulation is even more real than real. So there's layers of confusion, obviously, happening here in this quote. How would it be that the vehicle on the road is not real, that the lab test is real, and the simulation is even more real than real? Well, the account that an engineer would give you here is as follows. Their analysis, the way that they're designing the vehicle, is not meant to withstand an impact on Soldier Field Road out here. It's meant, they're designing to withstand an impact in a laboratory sled test, which means that they're going to take the car, they're going to run it into something that resembles the bumper of a Ford F-150 pickup truck. Resembles it, but it's not a Ford F-150 pickup truck. And that is the thing that they're designing the vehicle for, is how well it does in that test. And the reason that that is the reality for them is that the federal government will decide whether the vehicle that they build gets a 5-star crash rating, a 4-star crash rating, a 3-star crash rating, not by how well it does out on the road, not when you and I are driving it, but how well it does in the laboratory test. So in their eyes, what they're designing for is not a real-world driving condition that you and I would experience. That should make you feel a little scared. But they're designing for a test in the laboratory. Now, if you go one step further to a sort of a thought experiment, which is what would happen if the federal government in the United States or in another country decided that it didn't need to certify vehicles in physical tests in the laboratory, but instead would certify them in math. So all I had to do was submit the results of my simulation analysis, and that would help to determine whether we get a 5-star crash rating or a 4-star crash rating. It's easy to see that their version of what the reality that they're designing for would begin to shift. So that's one reason why they say the simulation could be more real than real. Another, though, has to do with the amount of data that's being produced. If I go back to this picture here, you can see that there's a camera behind the truck bed here that's looking into the passenger cab. What you can't see is that the number of sensors that are put all over here. The data that engineers will get from a laboratory test is actually quite sparse, compared to the simulation model, where they can decide that they want to take a reading here, anywhere, after the simulation has already happened, right? So I can post-process results in a way that provides me almost an infinite number of data points. If I want to understand what's happening behind this piece of sheet metal, I just click my mouse and that sheet metal disappears and I can watch all the structural members of the vehicle. If I want to find out what happened behind the sheet metal during this crash, I have to put in a work order. I have to hope that it wasn't damaged in the wrong kind of way, that they can't extract the sheet metal from it without damaging the structural members behind it. Somebody has to get paid to go over and do that at the proving grounds that's 60 miles away from my engineering facility. So their amount of learning that comes from the physical model is very, very different than the amount of learning that comes from the digital model. So their inspection of these produces a notion that this is a far more accurate representation of the reality of the dynamics of a vehicle than the simulation test in the laboratory, because remember that also is a simulation, right, of a real-world driving condition. But the consequence of their activity is indexed to what goes on in the laboratory, right? Because that's real, because that's where the government is doing its testing. So if you're more confused than clarified at this point, you're with me. And this is why I was motivated to continue exploring how simulations and sort of the digital manifestation of simulations aids decision-making and the organizational practices that go along with this. And as I started to think about this more and more and do a bunch of reading, I began to wonder about this intermingling of model and reality. And one of the literatures in the sociology of finance that deals with this question is about the way that models perform realities as opposed to simply representing them. And the canonical example here comes from Donald Mackenzie, who's a sociology of science and technology, who talks about the creation of the Black-Scholes model for options pricing, and how the Black-Scholes model didn't simply reflect sort of a difference in options price, but instead produced an environment slowly over time with lots of modifications in which people began to trade in a way that made the predictions of the model accurate. Okay? And so if you think about this crude model that I put up here, the idea is that the model in some ways is shaping the behavior of actors that changes the reality that the model is purporting to predict. Over time, of course, there's a feedback loop, right, such that as reality begins to shift in certain ways, the models adjust to take account of that. So you get an ever-tightening spiral, right, between model and reality. Their argument for this is that models in some cases can become performative, right, that they're no longer representative. As an engineer at my field site might tell you, that it's supposed to represent a system, or it's supposed to imitate that system, like the definition I gave you to start this talk. But what's happening here in their argument is that the model is actually conditioning a reality or producing a reality. There are a number of examples of this happening, mostly in finance, options pricing, arbitrage trading, commodity auctions. So there's a burgeoning area of work, of course, in the sociology of finance. There's some in organization studies and technology, right? You could read and interpret some of Vonda's work, right, as making this kind of performative argument as well. What's curious, though, is that if you read a little more fine-grainedly in these different literatures, what you begin to see is that the models that occupy the empirical focus of much of these studies are not the only models that were available to be market-shaping or to be performative. In fact, there are many other contenders, right, different modes of prediction, different simulations, if you will, that could have the potential to create a reality, but that do not. Daniel Beonza and Fabrizio Ferraro offer a good example of this in the area of socially responsible investing, about a firm, a new tech firm, that was trying to, this sort of idea of model performativity is spreading into the actual practice of finance. And these investors in this firm understood about this, and they tried to create a tool that would be market shaping, that people would use in order to create a more socially responsible, investment-friendly market. And their tool failed, right? It didn't work. And if you read through McKinsey's, he's got a book and several different articles about Chicago Board of Trade. There are different models other than Black-Scholes, for example, that were contenders to have had market-shaping potential, but that market-shaping potential didn't arise. So one of the contentions that I think is there in the literature is that as a precursor to something becoming performative, for models creating a reality, that the model has to in some way be taken as, or to be seen as, to be understood as, a reality in its own right, for somebody to act on it as though it is real. And the interesting empirical question becomes, what does it take for someone to see a model as real? Why is it, if we went back all those slides, that engineers at this automotive company would be duped in some ways into thinking that the model was the vehicle that was going to be built, that the model was the reality, as opposed to the representation of a potential reality?
So just so I
Yep.
can understand, just so that this is a little bit concrete for me.
Yes.
Where do these models come from? Are these simulations of things that just don't exist, or are these derivatives of things that do exist? Are they experimenting? Are these brand new products that they're trying to create?
Mm-hmm.
Where do they come from?
Yeah, that's a great question. In the literature on the sociology of finance, they are theoretical models that are built by academics that are trying to describe sort of the rational behavior of markets, for the most part. I'm overgeneralizing here. But the Black-Scholes model in particular was based on a set of theories that promised to exploit, or to identify and then exploit, price differentials in options. And so the theory basically would say, if an option looks like this, it's underpriced or it's overpriced. And Black, who was one of the primary contributors to this, created a set of sheets that were called Black sheets that were distributed to traders. And the calculations were sort of embedded on the sheet, such that if you looked at it, you could do a real quick summarization to see if a model was overpriced or underpriced based on this theory, and then buy or sell accordingly. And their argument, of course, is that this wasn't reflecting true pricing, true price differentials, but created investments that made some options do better and some options do worse. That's what's going on in the sociology of finance. You'll see when we get to my discussion of urban planning here in a minute that the models look different than that. But they are hypothetical, in particular because the ability to identify any kind of ground truth, as modelers call it, is very difficult because of the complexity of the models in urban planning, but also the time scale at which you're trying to build a model. So those will become important factors that we'll talk about in a couple minutes. Yes?
From a theoretical standpoint, could you clarify what you lose if you start looking at a model's reality versus a representation? Is it you start to forget the nuances of the reality or the risks involved?
That's where I'm going to get empirically in a couple of minutes. I think that if you're right to ask that question now, though, because that's partly what motivated me, right, in looking at this is, okay, so models make the world. If you buy into that way of seeing, do we care? Like, does it matter? What are the consequences associated with that? And that was part of what was interesting to me from an empirical standpoint, which is that if engineers do believe that this is the reality, right? If urban planners believe that this is the reality yet to come, what are the consequences of that? maybe it doesn't matter, maybe it does, and I'll show you some evidence that hopefully will convince you one way or the other. All right, so in my quest to sort through how to deal with this confusing issue of there's models and there's realities, and models shape realities, but models reflect reality, and are they representative, or are they performative, or does it matter at all? I turned to the easiest clarifying source I could find, French sociology, to help make some sense out of it. Jean Baudrillard wrote this influential book and a series of essays associated with it in the early 1980s, but it wasn't translated into English until the 90s, called Simulacra and Simulation. And what Baudrillard, through a dizzying array of examples from early reality TV to Disneyland to psychedelic rock of the 1960s, provides an interesting, but I think useful, exploration into something that he terms a simulacrum. And I'll get to what a simulacrum means in just a second. But here's Baudrillard's argument in a nutshell. That simulations always begin as representational, as an imitation of by one system of another system, exactly like the definition that I laid out for you to start the talk. But he suggests that as simulations grow more detailed, that they move from high levels of abstraction to more specific granular forms, and they take on more data points, my term, not his, that simulations come to start not only to represent a reality, but to become a reality in their own right. These are my terms, not his, but the more objects that appear within a simulation, the more parameters that we estimate in our equations, the more measurement points that we use, these are all ways that a simulation model becomes more granular, that it moves from a sort of macro state to a more micro state. Now, what Baudrillard argues is that when a simulation becomes so fine-grained and so detailed that people begin to treat it as a reality, that it loses all indexicality with the system that it's supposed to represent. And the classic example that Baudrillard gives is Disneyland. Mm-hmm. And so if you've gone to Disneyland at some point in your life, and you've been to Main Street, USA, which is sort of the central thoroughfare that leads to the Enchanted Castle in Disneyland, you will recognize that it is a simulation, right? It's a simulation of a typical or quintessential Main Street in somewhere in the United States. Now, show of hands, how many people have ever seen a Main Street that looks like this in the United States? Right, rhetorical question, of course. And this is part of Baudrillard's argument, is that in its goal to try to be a simulation of something, it takes on its own set of properties. Now, he argues, and you might dispute this, that if you've not had an experience with a Main Street USA before, let's say you come from a big city and not a small city, or you come from a foreign country, you can often mistake this for the reality that it's supposed to represent. His argument, though, is that it doesn't really matter if you mistake it or not, because what's important is that the simulation becomes a reality in its own right that people contend with. And they walk away having had an experience that they've been to a Main Street USA. And they have been. Yet that Main Street USA that is supposed to be representational is no longer representational. The clearest argument that I can find to summarize Baudrillard is his drawing on this fable from Borges about cartographers. If you're familiar with this, there's this fable that Borges talks about in the openings to one of his books, that there was a very diligent king who wanted to have a map of his territory. And he kept inducing the cartographers to make more and more detailed maps. And the maps became so detailed that they became so big that they had to overlay the map on top of the territory, right? Because it was so detailed. It no longer represented the territory, it was the territory. But of course, it's not the territory. It's a representation of the territory that we often confuse for the territory. Baudrillard will argue that when simulations take on this property of creating a reality unto themselves, and they lose their referential indexing with an external reality, that they become what he calls a simulacrum. And a simulacrum is the state of something being a system unto itself that we focus on, we act on, we decide on, we treat as though it is reality. Shane.
Okay, so is there a difference between, you'll forgive me, the Weather Channel and Waze? So, and is it important? So, what I mean by it is you can go on to weather.com and you can get a map of the weather as it's moving, and I will react to that because I see rain coming. I can also get onto Waze and see the delays on the highway, and I will react to that. But the very act of all of us reacting to that then changes what appears on Waze the next moment.
Yes.
Whereas in the weather case, it doesn't matter what I do, it's going to rain anyway. So is there a difference between those two examples in that one of them, they both generate behavior, right, in the sense that I hear you understanding, and I experience both of them as realities in the sense that you're describing Disneyland. But in the latter case, in Wade's case, the behavior generates this feedback loop, and that makes it different.
Wonderful question.
Yeah.
One of the sites that I mentioned, this is part of a larger comparative study, is with atmospheric weather scientists at NCAR in Boulder, Colorado. And so they're not doing climate change, they're doing weather science. And they're the ones that generate a lot of these maps that then get diffused out to the local weather channels and the Weather Channel. What I would suggest, having spent a lot of time with these folks, is that they have the opportunity to be equally performative, but on a very different time scale. So on Waze, it's very easy to see that if I'm driving down the 405 in Los Angeles and Waze says there's lots of traffic here, we predict, right, because they have a bunch of algorithms that are making a prediction that if you take this side road, you'll shave off 5 minutes, and everybody starts taking that side road. Well, that is not so much an example of performativity, but what McKenzie would call counter-performativity, but Rory can explain that to you later. But you can see how the prediction produces a behavior that then has an effect. In atmospheric weather science, the weather scientists will argue that their models can actually do the same thing, but over a much longer time horizon. And so they work with a number of different constituents, like energy companies, and they work with Department of Homeland Security. And what they're trying to do is predict weather patterns in the service of deciding if there's a threat of an airborne illness, right, moving across the country, or where to place wind turbines. And they argue, especially in the energy sector, that some of their predictions are used to make changes to the natural environment, right? Because the optimal placement of these turbines or this hydroelectric station or whatever will actually change the physical environment in such a way that it produces micro-level changes in weather patterns. And so that doesn't happen at the same time scale that it does on Waze, where 3 minutes later you're going down the road and there's full of traffic. But you could imagine a scenario in which it's doing the same thing over just a much longer time horizon and at a bigger scale. Yeah. Okay, so Baudrillard was helpful for me, at least, in thinking through this idea of simulations becoming more detailed and more granular. Sherry Turkle, who's just across town here, also has done a lot of work thinking about simulation and published this lovely book about a decade ago called Simulation and Its Discontents. She's great at titles. I am not. And what she does in the book is kind of recount a series of case studies that she's done with MIT faculty and students over a 30-year period, looking at the introduction of simulation tools into a variety of physical sciences, chemistry being chief among them in her explanations in the book. And she recounts in sort of rich qualitative detail how over this period of about a 30-year span, professors at MIT, particularly in chemistry, become increasingly concerned that students really only understand how simulations work and that they don't understand how the physical world actually operates. And their concern, in large part, is based on the notion that the simulation really is only a representation of the physical world and doesn't have all of the data points in it to accurately model what's going on in the physical world. So you have to know what the limitations and the assumptions and the algorithms are to be able to account for them in understanding the recommendation that the algorithm is giving you. And she sees that what happens is over this time period, students get less and less familiar with the physical and more enamored with the simulation. And part of her argument for why this occurs is that there's a second dimension here, which is that over time, simulations have become more and more immersive. Now, by immersive, I don't mean to suggest simply that the outputs of the simulation are more compelling, right? That now we have fancy 3D models rather than 2D graphs. But that immersion is linked in some way to this second dimension. They're not orthogonal, right? That as models become more micro and have more and more details in them, it becomes easier to envision yourself inside the simulation, or it becomes easier to get an understanding of, perhaps you think, what's happening inside the simulation. And Turkle gives lots of really interesting examples about how students in particular come to feel like that they're embodied within the simulation, even though the simulation is on the screen and they exist in different planes. But the immersiveness of the simulation makes it feel as though it has a concrete reality to it. So what I began to wonder, using these as some backgrounds, right, is that if the micro level amount of detail and the sort of level of immersion of a simulation matters a lot for whether people believe a model is reality. You know, could you, and that's the part I'm not really sure about, so you can give me some feedback on this later, but could you kind of array these as different orders of simulation? You know, where you've got, let's say, something that is, you know, very, very macro, but is not immersive at all, right? And that's very general and broad, right? We've got some kind of plan of action. But if you move into the opposing quadrant here, when it's very micro, it's very immersive, it becomes very easy to be sort of seduced into, becomes very easy to be seduced into the simulation. Did we lose some power?
There we go.
No, no worries. Well, I can keep going. So, those quadrants are not extremely important for what I'm trying to discuss, other than that I think it's possible to end up in different versions of, or different regimes of simulation, right? Where we can see a simulation merely as a prediction of something that might happen, as opposed to if we ended up in this kind of quadrant over here, we might treat a simulation as though it is a reality, right? And we begin to make choices about that simulation that may end up having some performative effects that produce the reality that we're purporting to describe. Okay? You following me, more or less, hopefully? Yeah, Rory.
Just, the original question was about how models can be seen as real, and thus there's sort of competing models out there, and one of them emerges. And I'm curious as why you focused on the details of the model itself as opposed to who's producing it. In the Black-Scholes model, you can think about academics at prestigious places as producing it, and therefore we think it's real and we use it. Or I thought about the related literature of reflexivity, and so U.S. News and World Report says this is how we're going to rate business schools, and so we act as if that's a reality or not. So why isn't that a piece of the analysis here? Why are you focusing solely on the characteristics of the simulation itself?
Yeah, interesting question. I think you'll see in the context that I'm going to study here with urban planners, it sort of lacks these high status players to be able to put their imprimatur on the simulation. I do think, though, that what I'll show you is that the production of the models in these kinds of ways is really an organizational process. And you could argue very similarly that affixing a certain kind of model, right, to a powerful individual, or a powerful individual claiming, or a powerful actor claiming that they have a set of predictions, right, that is going to kind of rule, is also an organizational process to some degree. So I think that the status and power issue is not salient in my context. Were it, I think what my speculation is, what you would see is that the power issue would come secondary to, or maybe be partly constitutive of, whether or not we come to see a model as accurate as producing a reality, right? So if we had sort of two competing models that appeared equally as real, and equally as real meaning that they were equal levels of immersion and granularity, that the one that has high status backers to it would probably prevail as sort of the ultimate guide to prediction. That empirically, though, doesn't exist in this context that I'm studying.
It's kind of fun that you have a context where that wouldn't be an alternative explanation.
But it's a good question because, I'm hemming and hawing a little bit in my answer to you, right? Because I first said that I think the model would come first and then the power would affect which one. But it may very well be the case that the details that get put into the model and how granular it is are very much affected by what powerful actors are around to be able to get their way about what gets included in the model and what doesn't. So I think that may very well be an effect too. Jerry?
The vertical axis here.
Yeah.
So I sort of got immersive. What is passive?
So passive, I was trying to think of what's the opposite of immersive.
Right.
Not immersive? I don't know. So I came up with passive.
Okay.
So if you can think of a better word, but it's when I feel like this exists at an arm's length from me, and I pay attention to it or I look at it, but I don't get involved in it. That's the sense I'm trying to convey.
Yeah, I wonder, so as you were going through all the different examples of simulation, where I see sort of a distinction is some of the simulations and the crash test are meant to predict reality, and so we're meant to have this interface with reality. When you go to Disney World, you're not going to Main Street to get an idea of what Main Street is in the real world. You're going to get immersed and not escape from it. And there are plenty of simulations like that, virtual reality, that's never meant to, you're meant to be immersed, you're not meant to, I almost would put predictive on the other instead of passive. So just wondering if that's a distinction here. You don't have to answer it, but just that's something I'm thinking about as you're going through these.
Right. No, it's a good point. Baudrillard doesn't talk about prediction at all, right? The goal of simulation that he's concerned with is exactly yours, right? Is that we get lost in this other.
Right.
And does it matter that the other isn't tethered to anything that's real out there? That it becomes a reality itself, right? So it's difficult to say that it doesn't represent something that's real out there. I guess, yes, there is something that it was supposed to represent at the start, but now it becomes its own reality, is the point. So I'm taking a move to add prediction to it because in all the context that I'm caring about here, the reason that we're doing simulation is because we're trying to make a prediction about the future. Mm-hmm. So I need to think more about where that fits.
But I guess where I'm intrigued by this is if you have immersive and call it predictive, and it's not a bimodal, there actually is you can be various stages along that, and at what point do we slip over from prediction to immersion? Anyway, that's what I'm thinking.
And I think we'll see some examples of that in the data coming up here. Yeah. Do you have a question?
Yeah, just a suggestion on the immersive versus passive label was just asked. I don't know if this is exactly what you mean, but you could also consider observatory or observational versus participatory.
Those are good labels.
Yeah. That's good. I often find that when I give a talk about a paper, I have some kind of figure in it like this, and then when I actually produce the paper, the figure goes away because they end up raising more problems than they solve. So, but I like that term. Thank you. Okay, so enough of French philosophy. Going into the sort of guiding empirical questions here. So what kinds of organizational decisions and actions shape the production of a simulation and that mode of reality, right, in which people operate? And then what are the consequences of operating in those resultant modes of reality? So do I treat something as though this is reality versus this is a representation of a reality or a prediction of reality? Okay, so as I mentioned, I've been engaged in this study for almost a decade now of looking at different occupations that are using simulation tools for the purpose of prediction. I started with automotive engineering after some of the dissertation work that I explained to you before, atmospheric weather science, and urban planning. And the reason I picked these in part was because simulations figure prominently in all of these, but that they're used for different purposes across these different occupations. So in the context of automotive engineering, they're trying to predict a future that will happen with some amount of certainty and in the very near future. In atmospheric weather science, they're trying to predict a future that could potentially happen. And in urban planning, there's a normative dimension to it, which is they're trying to predict a future that should happen. And as a result of these kinds of differing commitments, there's a different focus in simulation. So automotive engineers are obsessed with correlation. So they're always trying to correlate something that has happened in the physical world to their digital model and make sure there's a tight coupling between those two. In atmospheric weather science, they're not so much focused on correlation because the past is not a good guide for what will happen in the future ever. What they're really focused on is error, like maniacally focused on error. All of their models are very, very specific about the error associated with their prediction. Because they don't know exactly what weather is going to pass. Weather is this big, huge, worldwide system. And so they're making a prediction, but they want to temper their prediction by discussing, right, the margin of error. And in urban planning, they're really focused on kind of plausibility. So they're always trying to say, well, if we did this, could we make it happen? Like, could we build a region that looks like this? So there are different driving concerns. And so this just set up for me a larger comparative study, right, that allowed for some areas of differentiation. But I'm going to focus here on the urban planning context, and more specifically, regional planning. And regional planning is something that is mandated by state and federal governments for major metropolitan regions above 200,000 people. And the idea is that you're supposed to project a long-term plan for the region, and they're typically in 20-year cycles. And they're about the growth of the region, so what kind of transportation corridors do we have, what sort of public transportation, what does zoning look like, and there's a whole number of outcomes that we're looking to measure, right? It could be income inequality, greenhouse gas emissions, and what those dimensions are will vary a little bit depending on what the state legislature wants in that plan, what the federal government wants in the plan, and so those shift a little bit. But generally, the roles in urban planning are relatively similar no matter where you go. And all of these will become important actors. So there are planners who have degrees in urban planning from prestigious universities many times, like the ones that you are affiliated with. And they're involved, they're sort of the shepherds of the planning process, and they know a lot about zoning regulations, and they work closely with modelers who are actually building the simulation tools. And there are usually two varieties of modelers. There's those that do transportation modeling and those that do land use modeling. And land use is mostly about zoning and zoning ordinances, and transportation, as you might imagine, is about traffic. There are politicians, because while plans happen at a regional level, this is important, regions have no authority to implement plans. So all that a regional plan can do is to say, if we took these 20 cities that exist in this region and we looked at them all together and we thought about the ways to best integrate them with zoning and ordinances and traffic flows and public transportation and whatnot, now we're going to take this plan that we think is a good plan for the region and the different cities and municipalities have to go in and make zoning ordinances, and they have to approve budget for highway restoration or public transportation infrastructure, whatever it might be. So politicians at the city and municipal levels are really important in this process. There are interest groups that are very key to this process. The interest groups are quite varied. There are the folks that represent the green movement. There are people that represent, they call them the equity position, which is making sure that there are that people from different ethnic and racial backgrounds are not being prejudiced against by a plan. There are developer associations, there are school associations, so you can imagine all the different interest groups. And one of the stated goals of the urban planning profession is that plans, and especially as sort of a civic service, is that big regional plans are supposed to have the input of the community, right? Public deliberation processes happen in every municipality and city, and the community, including the citizens, but the interest groups, are invited to come to public meetings and opine on the plans and give their thoughts and ideas. And the planners are, kind of by the logic of the profession, supposed to take that input, think about what's feasible in the context of cities and what their goals are, develop models that then will make predictions about a future, and ultimately together as a community we sign off on a plan, if that makes sense, okay? So that's kind of the big messy process of urban planning. And I was fortunate enough to do a comparative study of urban planning or regional planning I should say, in 2 different areas. One's the San Francisco Bay Area and the other it was in Albuquerque, New Mexico. And the reason that I was able to use these 2 sites was that they were both using a new simulation tool for urban planning called UrbanSim that they had not used before. They were both at the same phase of their 20-year plans. You can see they're both planning for 2040. And so they were both going through the same kind of process. And they had all of the same stakeholder groups in them. So in some ways, not a perfect match sample. The socio-political context is of course different in those locations, and that will be important later. But they had the same kind of infrastructure, the same timeline, they were using the same technologies. And so it presented a good case to take a look at how the use of these tools for purposes of prediction played out in both. Okay. So I'm going to take you to somewhat of the end of the story now in the method section here, which is to say, how did citizens and politicians in particular orient towards the results of these plans, right? So as the plans are kind of being formed in the public domain. And what I'm going to argue is that in the Bay Area, San Francisco Bay Area, they fall mostly into this category of the model is reality. And you can kind of hear it a bit in this quote. He says, the highway is there. And this is at a public meeting, and he's pointing at a model. And he says, the highway is there. That's the problem. It can't be there because it displaces black and brown populations and moves them away from public transit. That's why we're suing them, because they didn't consider the equity position. We need to get rid of that highway. Now, this is a very interesting quote, but it's also an interesting movement, which is that there is this group called Public Advocates that advocate for racial and ethnic minorities in the San Francisco Bay Area. And they looked at this plan as part of the public deliberation process, and they said, this plan is discriminatory. And it's discriminatory because it moves housing away from public transportation hubs, which is where most of people in the black and brown communities live, and it's going to make it much more difficult for these folks to get to work, and it will disenfranchise them economically. And so they decided to sue the city to say, this is a terrible plan. Now, remember all the things that I've told you so far about urban planning, that they're planning for 20 years out into the future, that they have no jurisdiction at all to implement this plan, that maybe it becomes advisory. But as the plan starts to get produced, they are engaged in a lawsuit to shape the plan even further, right? And when I asked this gentleman about why are you suing, isn't this just a prediction of something that could happen in the future? He's like, no, this is what's happening, right? If we don't sue, this is reality, was his words. Now, interestingly, they sued the city and said, we don't like your analysis, redo it. So the MPO, Metropolitan Planning Organization, redid the analysis and came back with basically the same result, is that we should put the transportation hubs here. And they said, well, we factored in all your concerns. So Public Advocates still didn't like that. So they subpoenaed the code to the model. Now, they didn't know what to do with the code to the model once they got it. So they hired a consultant from UC Davis to go into the code and look at how the modelers were parameterizing the model and suggested new parameters that the modelers should use. And the modelers used those parameters, and it produced a different outcome that Public Advocates was happy with. So you can see that their intervention in the very process of producing a plan is actually shaping the very model that becomes the recommendation for what will happen in the future. But the feeling of these people that's involved is very much that this is the reality that we have to fight for. It isn't a plan that may someday happen. It becomes a reality in its own right. Jerry, do you have a question?
So the highway doesn't yet exist?
No, the highway doesn't exist.
Got it.
Which is important.
Yes.
And that's very different from what goes on in Albuquerque. And listen to this language from a public meeting. If we rezone that area, commercial things might change. What they showed us is several options for how it could change. Could. Any one of these could happen. it's good for discussion. That's why we're here, to see what we all think about it before we make any plans that could set things in motion. Right? There's a very different orientation in these two areas to what is the thing that we're being presented. Is it something that's sort of fait accompli, or is it something that is very tentative and open for discussion? And the question empirically is like, how do we get here to these differences? So this is primarily a study based on interviews. We did 110 interviews across these two regions with
Go back to your, I'm sorry,
yeah.
just real, is there a difference here? But so there is a difference here in the examples of what
Yes.
you're showing us, that a highway, once it is down, it is down.
Yeah.
A zoning, may or may not result in something.
Mm-hmm.
Is there just in this, like.
Oh, you're saying, so is the example materially different in the thing? That
Yeah, I mean, so basically, is it the attitude towards the simulation or what they're talking about here?
Mm-hmm.
Because once a road is down, it's down. You can always rechange zoning, and zoning doesn't necessarily lead to something in particular.
Yeah, good question. There are multiple examples of things
Okay.
with varying levels of permanence across
Okay.
the two.
Great.
So I don't think, anyway, that it's attributable just to that.
Okay.
Okay, so we did a bunch of interviews with all the stakeholders across the two areas, lots of observations over a period of a year, including public planning meetings, and you can go, most of these meetings are public, they're all public and they're posted online. You can go to YouTube and you can find them and see the heated discussions and the way that things are being said, and it's very interesting. I've never collected data like this before that's so public. And then of course, planning process generates lots and lots of documentation. And so there are lots of documents for us to review about what their strategies were, what decisions they made, and all those kinds of things. Okay. I want to give you an example of two ways to present simulations. This is one. This is a plot that basically looks at density. And you can see that there are different zones that are represented here, and the density is represented in this graph. Often what planners will do is they'll come to a meeting and they'll talk about density against sprawl or density against zoning, and they'll present a chart like this. And you can imagine that even just to the public, right, these are difficult to interpret. The tool that we studied, UrbanSim, could produce charts that look like this, and often did, and people marshaled these charts in the course of interaction and in private meetings within the metropolitan planning organizations and in public meetings with interest groups and citizens. But it could also produce things that look like this. This is just a 3D still, but you can see that what they've done here is that they've changed the zoning in one area, and that pops this little blue building up to multiple stories because the zoning is different. And so if you run the animation on the simulation, you could simulate what traffic flow would look like along 3rd Street based on whether this is zoned commercial or zoned residential or zoned for 5-story buildings or 3-story buildings. So you can see that not only, of course, the output is different here, right? The medium that we're operating in is different. But the level of granularity is much greater, and the level of immersion is much greater on the output end. But what I'll also argue is that the actual model itself is much more granular when we use a tool like UrbanSim, or it can be, such that we could actually produce a very, very detailed output like this. Okay? And so as you might imagine, it's much easier for people that are sitting in a room, kind of a public that's not familiar with urban planning, to look and see 3rd Street turning red, which means there's a lot of traffic congestion. But when we back off and only allow 2-story buildings in this area, this is San Francisco, that traffic flow is much easier, right? Yes?
It's not pertaining more to like disaster analysis, but how do they communicate any like rare events or like worst case scenarios of what might happen when you introduce this policy, or do they just kind of look at the general averages? Or
no, I've never seen in all of our observations or interviews that they're doing that kind of disaster analysis. What they're really mostly looking for is the effects in normal use cases of particular decisions. What UrbanSim is doing behind the scenes is this. So there are all different kinds of models that go into the UrbanSim tool, and you can see each one of these represents a different kind of model, right? There's a jobs and household model, there's an employment model, there's a travel data model, there's a real estate development model. And within each one of these, if we just like click on the real estate one, right, there are all of these different data and variables that are basically being modeled here to produce this that goes into the overall simulation tool. Okay, so it's a very complex set of interactions with lots of data points. Now, unlike automotive engineering, we have this controlled environment and I can build my simulation and then I can test to see how well it correlates to the thing that happens in the laboratory. These are so big and so messy and the data are so imperfect that I can't ever truly correlate my model that I built for the region to, with what exists in the region today. And so they're always making a simulation, which is a perturbation of those baseline assumptions for 20 years in the future without a very strong correlation based on the data that exists today. Now, the tool manufacturers will argue that we do the best we can, we have statistical techniques to deal with missing data cases and things like that. But the ability for the model to be accurate is it's much harder to do in urban planning.
So there's two different things you could be saying here, so just a little clarity. One thing is you make a prediction and then you don't put if I can be a statistician for a moment, you'll put a standard error on it.
Right.
Yeah. So you don't say within the 95% likelihood, it's a big range. Right? That's one thing you could be saying. And so they fail to do that. And so the failure to make such a statement then fails to communicate that the point prediction could be across some large range. Right?
Exactly.
There's that. There's a second thing that could be going on, which is the model itself fails to account for, because we could only bring in so many details. It fails to account for, in your example, what a Giants game will do to traffic, because it's nearby. Right? And which is periodic and it's too much detail and we can't really predict that. So you can't do a standard error on that. That's a statement of it's outside the model and we don't know what that could produce. So you could be saying either one of those.
Right. Right now I'm saying the first.
Okay.
That they're not computing a standard error essentially. Right? And they will argue that they can't do it because there's not enough data to be able to do that. What I will show you empirically is the results of the second thing in just a second.
Oh, okay.
That what's going to happen organizationally here in a moment is that different decisions they make about how to organize the work provide more or fewer opportunities to build in externalities like a Giants game into the model. And what we're going to see is that's going to happen a lot more in the San Francisco Bay Area than it is in Albuquerque. So I'll explain, that's right where we're going now. Okay? Okay. So the first question here was, what are the organizational decisions and actions that shape the production of the simulation? So there's this broad vision for planning to start with, right? That has to get turned into a model. So like we want to reduce greenhouse gas emissions or whatever the objectives are. So that somehow needs to get operationalized in terms of a model. And modelers will talk about how this is, difficult to do. And so the modeler says, it's a science and an art. We have to come up with numbers, which is pretty difficult. People are like, oh, I want a shiny train in my city. And I'm like, well, your city is spread out, so no one's going to write it because they all have cars. And they're still like, no, I still want that shiny train. Sometimes interest groups really want something, but I feel that my understanding of the world, which is informed by a model like this, a simulation system, is more rigorous or thoughtful for the long term. And really what he's sort of objecting to, right, is that there's this broad pie-in-the-sky plan. It has to get operationalized in some way, and it's his decision and the other modelers about how those things get represented in the model, and what initially at least gets represented and what doesn't. What's more important, though, is that in that process of turning a vision into a model, there are a number of organizational decisions that are getting made that are going to influence the granularity of that model. And this is exactly the point that you were raising as a second possibility. And the major difference that we saw across Albuquerque and the Bay Area was about the decision to hire modelers on staff that would do this translation work from the vision to the model, or to hire modelers as consultants at an external firm. And here's the major difference that happens between the two. When we create a modeling arm in the San Francisco Bay Area, the modelers will say that people will come in, so Shane will come in to my office as a city official and representing the district south of Market in San Francisco, and say, I don't think your model really incorporates very well a series of periodic events that we have here, which are called Giants games, right? At Pac-Bell Park, or whatever it's called now, it's PC Park, or I don't remember what it is now. And that needs to be included in the model. And so the modeler will then include that in the model. Once that's in the model, and the next person comes, that stays in the model, right? And so the next person comes and asks for something else, and so that gets included in the model. And the next person comes and asks for something else, and that gets included in the model. And so the model begins to grow and grow and grow and grow. And if you just look at the file sizes of the models, controlling for the complexity of the area, it's exponentially bigger in San Francisco than it is in Albuquerque. And part of the reason that this happens, right, is because they're in close physical proximity, so I can easily walk down the hall and I can go talk to the modelers. If I'm a planner or I'm a city official, I can get there. It also doesn't cost anymore, ostensibly, to go to the modelers and ask them to put something in. I don't have to do a change order to my consulting contract. In Albuquerque, they're very judicious about adding extra things into the model because it's a time-intensive process. There are communication challenges with communicating that to the external consultants, and it's also a fairly expensive process because every additional thing we're asking them to model costs more money, and we have to issue a change order on our contract. And you hear that here, right? So in San Francisco, in the Bay Area, they're saying this is embarrassing in the sense we're basically fudging the model to make it work and come up with results that people seem to like. The management liked them, but I didn't particularly like how they came out. And I think there are lots of holes in the models, and there's lots of things that were unexplained. You know, someone said, well, why don't you just move all these things over here? I mean, just move all this growth over there, just like pick it up and move it over there? Sure. So I pick it up and I move it over there because somebody asked me to. Now, you might decide you don't like that, but that has created more granularity in the model, because that doesn't go away, right, once I've built it and created it. So the model becomes increasingly granular. Where in Albuquerque, it doesn't. We knew we needed a land use model. We've been working for a couple years with somebody who developed our previous land use model to try to migrate it into more of an urban sim type framework. We realized that we needed a column developer because we didn't really have the expertise in-house to do our own programming, right? And then they go on to talk about how calling on developers is this really onerous process, and nobody quite speaks the same language as them because they don't have the repeated interaction to even articulate how to put the things into the model that they want. So what we begin to see is this make versus buy decision is shaping to some degree how granular the model becomes. But there's a second one that's quite important, and it's their orientation towards their boundary permeability, I guess I'll call it. And that is, how much do we want all of these external stakeholder groups to really be involved in our process early on, as opposed to comment on our process once we've built a model? And San Francisco and Albuquerque had very different orientations towards this. And so in the Bay Area, they had this very open systems kind of model, which is anybody could come at any time. They could, you know, if you were a developer and you had a complaint and you didn't like our model, you could stop by the office and come and talk to us. They were very accepting of lawsuits, and in fact, the director of the Metropolitan Planning Organization told me, we just expect people to sue us. It's just kind of part of the process, but that's good because it means they care, right? And in Albuquerque, they kept people at a much more arm's length. Now, I think part of the reason for this was that the political groups are much better organized, and they've got more money, and they're more powerful in the San Francisco Bay Area than they are in Albuquerque, right? So they demand more of an open, interactional style. Whatever the antecedents are there, though, there's a major difference, right, in how sort of porous our boundaries are and how open they are to it. And I won't read these, but every time, you know, somebody comes, right, from the community and like, wants this, or public advocate sues, right, and asks for this new thing to be put in, again, the model begins to grow, and it becomes more and more granular. And if you've kind of followed my logic so far, part of what's happening as the model becomes more granular is it becomes easier to identify with the model, and it becomes easier to think of the model as though it's not a representation of something else, but it is its own thing. Okay, so decisions about organizing shape the granularity of the model, but decisions about organizing also shape the ways that workers communicate with the model. So if you are a planner or a politician in Albuquerque, you know way less about how urban sim as a technology works, So it's difficult for you to answer questions about it. It's difficult for you to make suggestions about things that we should do differently. But because when in the San Francisco Bay Area, we're working closely with these people, we develop some shared language and understanding with them. We have a better intuition about the underlying things, the models and assumptions and calculations that are going on behind the model. We just developed kind of more of an understanding. And that really shapes how people communicate about the models, which I'm going to argue kind of shapes its immersiveness. One of the moves here is that there's a difference in whether the simulation tool takes front stage in discussions about planning versus is backstage in discussions about planning. And you can see, again, I won't read these just in the interest of time, but here, this is at a public meeting, and you can see how they're actively invoking the model, they're running the model in real time in a public meeting, they're talking about what's going on with the simulation tool. And in Albuquerque, this is a description of the planning meeting. They say, the model itself was really just described as a tool. We kind of downplayed it. You know, we didn't really talk about the specifics of what was going on. We just talked about attractiveness and so on and so forth. So here, they're very front and center that we're using this tool called Urban Sim, and it's helping us to do the simulation, and so on and so forth. And the discussion of the technology really moves to the front stage. And so people ask questions like, well, can you slide this over so we can see what it looks like then? And here, they don't even know that those are questions that they could be asking.
It's almost as if the left one is a it's approaching crowdsourcing. I've been hesitant to use that phrase, but it's as if it's approaching crowdsourcing, and it's only on the unincluded aspects rather than the standard error aspects.
Yeah.
Right? Is that the right way to understand it?
I think so. And the planners would generally say that's a good thing, because
Yeah.
that's our job, right? Is that we should be crowdsourcing ideas from the community about our plan. We, as public servants, we're not responsible for deciding what this region's going to look like in 20 years. It's the community's decision.
Yes,
and
so it makes it very focal.
It does.
Yeah.
It does. Absolutely. The other thing that happens here is sort of the dynamism of the data, right? And how facile the planners are and the politicians are with being able to talk about the data and present the data. And so here on the left at the Bay Area, because they've got more facility with the models, they're able to do more things with the data, represent them in different ways, and be able to produce images and animations and things that sort of capture people's attention and pull them into it. Where here, this person just says it great. We show the trend lines and people's eyes sort of glaze over. But the trend lines are the best way to explain what's going on. All the data are right there. Come on, people. You know, we do a really good job of explaining it, I think, but people just don't seem to get it, right? And so they're less able to sort of deal with the data, show data, present alternatives, and these kinds of things. And as a consequence, the data, the outputs that they show are much less immersive to the audiences that view them. Now remember, immersion is also a function, I think, of granularity. Right? We can get to that more fine detail, better representations, visual representations of it when we've got more data and more assumptions built into the model. Ethan?
Particularly the last slide on the front stage, backstage, or front stage, backstage, but also on that. Is your intent for us to then think back to the story you told us about the GM engineer who said, this is more real than real because that's what the government cares about? Are these people actually living, are we getting to the point where we're thinking, if I'm in San Francisco, the model is going to decide. If I'm in Albuquerque, I know that elected official said to me, we have a chance to decide later. Do they feel like the door on decision making is closing? Is that part of this too, or is that separate from whatever you're suggesting?
Yeah, so that's essentially what I mean by the model becoming a reality, right? That, you know, if we don't, the thing that we see here is nearly complete. It's nearly done. And without our intervention in this process, what's going to happen is that this will become our built environment, this model right here. Now, there's a whole lot of abstraction that moves from that point to, will this thing ever get built? And in fact, the history of regional planning tells you that the things that are planned rarely ever get built. And for a lot of the reasons that I suggested, right? Funding changes, they have no jurisdiction to build any of these things in the first place. But the heightened sense of like, we have to act because this is the thing that's going to get built is very, very, very salient in the Bay Area and not in Albuquerque. But it's no less real in Albuquerque than it is in the Bay Area, right? They've got just as much authority to implement the plan than it does in the Bay Area. But the folks in Albuquerque, the citizenry, right, and the folks in the cities, don't get the sense that this is the thing that we're going to do. That's kind of the crux of the difference. Okay. So what I've tried to convince you about so far is that these decisions about how to organize work are really shaping the granularity of the model, how granular the model is. And that those decisions about how we organize work help facilitate different kinds of work behaviors that are also shaping the immersion of the model. And based on this, we have sort of different trajectories or different varieties of reality that we're contending with in Albuquerque and in the San Francisco Bay Area. Now, the consequences, and this is just kind of short to end, I think are kind of interesting and somewhat paradoxical, right? So if you think that Albuquerque's like over here, that they still view this as a prediction of what could happen in the future, no foregone conclusions, we have plenty of time to figure this out, versus what we decide here is the thing that's getting built. What we see is that there are different effects on two key dimensions that are really important to urban planning. The first is what Shane mentioned, is the crowdsourcing dimension, what urban planners call stakeholder engagement. You want high stakeholder engagement, right? You want lots of people from the community to be involved and invested. And we see that it's stakeholder engagement is high in the Bay Area, and it's very low in Albuquerque. And that shouldn't be surprising based on what I've shown you so far. But the second dimension that's really important for urban planners is about the generality of the discussion of the issues that we're having. And what you really want is to have a high level of generality of discussion rather than a very granular discussion. And what I mean by that is the following. Well, actually, I'll just let the people tell you what this means. So first, stakeholder engagement. You can see that in Albuquerque, they say public involvement is so bad. You have these few little meetings and you ask people and they provide comments and your comment form is this blank sheet of paper. And I want to know what you think about this and this, right? They're not telling us. And in the Bay Area, they just, story after story. The Tea Party got the perception that we were going to take over, so they started coming to our meetings, being very disruptive, and we were all puzzled, and it became a crowd management issue. There's tons of stakeholder engagement over here, and almost none over here. Now, the generality of discussion, though, is a little bit different. And these two quotes, I think, illustrate the difference nicely. So in the Bay Area, where the discussion is very focused on specific issues, it looks like this. We don't like the concept of a 5-story high-density building there. Why does it have to be 5 stories? That's a bad development plan. We need fewer stories. Can we agree on less of a build-out? So this is like, you hear all the time, not in my backyard. These are the NIMBYists over here, right? That are looking at this, and the plan is so detailed and so immersive that I can see, I can visualize that this is already happening, right? Hooligans are taking over my neighborhood. I bought this quaint little house, and there's going to be sky-rises all around me. This is terrible. I protest. But what that discussion and that complaint obscures is the larger issue about, do we want high density in this area of town versus that area of town? It's not about your house, right? It's about what do we want as a region. And that's what's happening in Albuquerque, sort of ironically, right? And somebody, this is a community member, said that discussion was a good discussion. We all agreed that we want a commercial corridor there. So it's not, my house is getting affected by this freeway and my building and my property tax is going to go down. But do we want a commercial corridor in this area? Urban planners will argue that it's this high level of discussion that's what makes for a good plan. But what's interesting is that on these two dimensions, treating the model as a reality gets you the stakeholder engagement, but it kind of forestalls this level of generality and discussion. And of course, that is good on some fronts and not so good on other fronts. Okay, so just about nearing my time here. What I tried to do is make a series of arguments, some empirical and some theoretical. So let's recap what those are. My first empirical argument was that we increasingly create our relationships with the world via simulation. Hopefully you're convinced on that one. And then the theoretical argument was that simulations can be differentiated along these two dimensions. Forget the 4 boxes or the quadrants, but just think of the dimensions, right? The sort of granularity dimension and the immersion dimension. hopefully that is a persuasive argument. The second empirical argument is that organizational communication factors can explain whether models become more granular and immersive, and consequently whether they're treated as predictions or realities in their own right. And then the final theoretical argument is that there can be this countervailing relationship between versions of reality and their outcomes, which is the last point. And I'm hesitant to use the word paradox or irony. I feel like I always use them wrong. So I'm going to say countervailing here, which is that we get one thing we want, but we get another thing we don't want. Okay, so I think there are a couple of implications that are a little bit more theoretical. One is I think that what the study can help us to do is articulate maybe what it takes for a model to become performative. So we see in Albuquerque a model taking on these performative characteristics that we hear about in the literature, in the Bay Area, but that doesn't happen in Albuquerque in the same way, and discuss sort of why that's the case. One thing I think that's quite interesting though is that if the model is treated as a reality too early on, then it loses its ability perhaps to serve as a really good plan. So if it seems like this is the thing that's already going to get built, then we end up fighting about these fine-grained things that maybe don't matter so much as being able to take a step back. And that was the advantage of what happened in Albuquerque, was nobody thought this was going to be an imminent build-out. And so they were able to take a longer view and have some discussions about what do we want the region to look like and how should it be shaped. I also think that it's important to note that simulations are seductive for all involved, especially the more granular and immersive they become. And while I've told this story primarily from the point of view of the public, the stakeholders, people that are not the modelers, I could have had an alternative presentation here where I talked about all the points where the modelers come to believe that this is actually, that their model is reality, like this is what the world is. And it was very much the same kind of warning that the auto engineering directors had that I showed you at the beginning, that they were afraid that their modelers were going to believe that the simulation was truth. And is that a problem? I'll leave that as a big question mark for us. But I think that it's interesting to sort of think through that process by which we begin to operate in the modality of models that lose a reference to the real world. What are the positive and negative consequences of that? The very last thing I'll leave you with is, lest you think this is just an issue for cities and product development organizations. I went on a trip with my family last summer, and before I left, I bought a new iPhone 10, I guess it is. And the first thing I did when I got home was I sat at my kitchen, we had an island in our kitchen, and I took a picture. My mom bought my daughter this card about preschool. She just graduated from preschool. I just was testing out my camera, and so I tested it out, and I looked at the picture and I thought, oh my God, my kitchen looks amazing. My kitchen does not look this good in real life. You know, it's much dingier than this. This pot is not necessarily that blue. My countertop does not look that veiny and beautiful. But this is not a picture of my kitchen. This is a simulation of my kitchen. Because there are two lenses on this camera that take pictures at different depths. There's a series of algorithms that stitch those pictures together. So if you look at this picture, it looks like it's representing my kitchen, but it's not. It's a simulation of my kitchen. And what's interesting about this is that I understand that this is a simulation of my kitchen, but if I post this picture, and I don't do this, and so they'll all get mad at me because I don't, on Facebook or Instagram, everyone else in the world orients towards this picture as though it is the reality of my kitchen, when indeed it is not. And so I think the consequences for how we think through the relationship between simulations and reality and representations is complex, it's nuanced, and it's important for us to consider. So I'll end you in the matrix here. Thank you.